My name is Adebisi Shegun Akomu. I have other co-authors like Professor Amuda, Omotayo Sarafadin, Imo Joseph, and Aziz Lukman. I am of the Department of Chemical Sciences, Osun State University, Nigeria. I was the former head of the department and currently the Dean, Student Affairs of the university. I teach chemistry in different areas: physical, analytical, industrial, and environmental. I'm to present a paper entitled Production of Biodiesel from Some Vegetable Oils. I would like to describe the abstract of my paper. Biodiesel generally is becoming prominent among alternatives and substitutes to conventional petrodiesel due to three major factors, which are economic, environmental, and social factors. The quality of biodiesel produced usually is influenced by the nature of the feedstock and the production processes absorbed. Certain things are detrimental to the quality of biodiesel, which are FFA, free fatty acid, and the hydroxyl groups that are present. The ASTM, and the FF recommended that the content of FFA should not be more than 0.5% in biodiesel, and that the FFA should have a viscosity of less than 6 millimeters per second. The properties of palm kernel oil and coconut oil were compared to those of the palm, and the results were compared with petrodiesel and ASTM and European standard. And the results show that the high amount of FFA in oils produced low quality biodiesel, and that can be neutralized with low amounts of FFA produced high quality. So neutralization can improve the quality of the biodiesel. We introduce by saying that vegetable oils are among the various sources of energy fuels being considered as alternative to fossil fuels. The biodiesel could be produced from rapeseed, soybean, sunflower, coconut, and palm oil. And they are the major raw materials for biodiesel production. But those oils are used as foodstuff and therefore are not usually encouraged, as this may lead to high cost of the listed oils. Non-edible oils such as jatropha and castor may provide better alternatives. And we know that there is a need for alternative energy sources to petroleum-based due to the depletion of the world's petroleum reserves, global warming, and environmental concerns. Environmental concerns such as ozone layer depletion, acid rain, and some other factors. Biodiesel is a clean and renewable fuel and is considered to be the best substitute for diesel fuel. Soybean could also be, the oil from soybean could be used to produce biodiesel for production. And United States of America is the current leading producer of soybean oil, accounting for 34.5% of the total. And that's followed by Argentina, China, Brazil, and India. Soybean oil could be used to produce ethanol, and that can also be used for another form of fuel. The biodiesel is can be used as a blend with other petrodiesel in ignition engines, either alone or combined. And the result of engine emission tests show that the use of biodiesel alone produces less emission of carbon monoxide hydrocarbons, and nitrogen oxides, NO, NO2, and the smoke, and also produce less smoke than petrol diesel. Conventional biodiesel production from soybean uses separate processes for oil extraction and biodiesel conversion. Currently, to produce a gallon of biodiesel may cost around $3.11, and the cost of petrol diesel is $3.0. And so it is important to make biodiesel competitive in the diesel market. So the objective of this study is to provide information and extraction of oil and production of biodiesel from palm kernel oil and coconut oil, and also to discuss the physical-chemical properties of the biodiesel produced. I'm not going to waste our time, so I will speak to the paper. Biodiesel, as mentioned earlier, could be produced from oil from palm, soybean, rapeseed, mustard, peanut, coconut, olive, jatropha, flax, sunflower, cottonseed. It could also be produced from rubber seed, grape seed, hazelnut, linseed, sunflower, sesame, corn, and rice bran oils. And it can also be produced from animals, animal fats, such as tallow, lard, yellow grease, chicken fat, and as well as the byproduct of production of omega-3 fatty acids from fish oil. And the production of biodiesel from algae has also received a lot of publicity from some authors, and it involves transesterification process, which employs the use of methanol and the oil in presence of sodium hydroxide. The sodium hydroxide is a base catalyst. It is preferred above acid catalyst in the sense that it is faster. Acid catalyzed reaction is slower. It's also preferred to enzyme catalyzed using lipase. Lipase is costlier. To use enzyme catalyzed is costlier. So the materials were palm kernel oil, coconut oil, sodium hydroxide, and methanol. And in the experiment, we use a 5-to-1 ratio of the oil to the ethanol, and using 0.7 grams of sodium hydroxide pellet. And the mixtures were mixed together. Sodium hydroxide and methanol formed sodium methoxide, and the contents were mixed at a temperature of 55 degrees Celsius and another time 60 degrees Celsius. We obtained for a period of 2 hours, after which the reaction was stopped. The separation was carried out using separating funnel for around almost 18 hours, after which there was separation of the biodiesel from glycerol. We first carried out a batch production before we went into the actual production, and that is the schematic diagram of the unit for the biodiesel production. At the top, we have the preheated oil at 55 degrees centigrade, and sodium hydroxide in methanol solution, and they were mixed together, and we have biodiesel plus glycerol, biodiesel on top because it is organic, and glycerol below. So it's less dense than the glycerol, and we collected the glycerol first before collecting the biodiesel, and it was later stored. So the results are presented in the table below. We carried out a physical-chemical properties on 16 different parameters And the result for palm kernel oil and coconut oil were compared with the diesel standard, the pH, the color, the refractive index, specific gravity, viscosity, flash point, fire point, cloud point, pour point, acid value, free fatty acid, peroxide value, iodine value, saponification value, and ester value. In comparison, the results compared, in some they were higher, in some they were lower. And our discussion is that palm kernel oil is edible, but less is not as edible. It's not much in comparison it's not much eating when you compare with palm oil itself. So majorly in Nigeria and other parts of Africa is usually employed to make soap, saponification. So is advisable to be used for making biodiesel. We discuss that it can be used to create biodiesel for internal combustion engine, and can also be promoted as renewable energy source to reduce net emission of the greenhouse gases of carbon dioxide into the atmosphere. And biodiesel is seen as a way to decrease the impact of greenhouse effect and as a way of diversifying energy supply to assist national energy security plans. And the palm is also used to make biodiesel, either as simply processed palm kernel oil mixed with petrodiesel or processed through transesterification as we have done. And that means the international EN 14214 specification with the glycerin as the byproduct. I want to go straight to our conclusion. Our study revealed that biodiesel could be produced successfully from PK oil, palm kernel oil, and coconut oil by alkali catalyzed trans-esterification. And the effect of different parameters such as reaction time, temperature, catalyst, concentration, and reactant ratio on the biodiesel yield have been analyzed. And the good combination of the parameters were found to be at a 5:1 molar ratio of oil to methanol using 0.5% sodium hydroxide as catalyst. And the reaction time at a temperature of 60 degrees centigrade and at a reaction time of 2 hours. The viscosity of the vegetable oil will reduce substantially after transesterification and is comparable to that of the petrodiesel. The recommendation is that the use of palm kernel oil and coconut oil for the production of biodiesel is promising, but there's going to be a slight change in palm kernel oil because the palm kernel oil solidifies at room temperature and cannot be effectively used in cold environments or cold areas. And the biodiesel properties of the samples did not deviate significantly from the expected values. The vegetable oil gotten from jatropha and castor bean may serve as better option for the production of biodiesel because they are not edible and they can hence be used as alternative fuel for diesel engines. In another work, we worked on used oil. So we consulted a lot of authors in the course of the work. So I want to thank you for listening.